Hello, this is Dr. Keith Miller, and I will be discussing the formation and classification of folds. But first, why do rocks sometimes fault or fracture in response to deforming forces, and in another case, form folds? To understand how rocks deform, we need to understand two terms, stress and strain. Stress is simply an applied force. Stress is described by the magnitude of the force, that is, how strong is the force, by pressing it a little or pressing it a lot, okay? And the direction, that is the force compressional, is it tensional, is it shearing? Strain, on the other hand, is how the material responds or changes shape in response to an applied stress. There are three types of strain: elastic, plastic, and brittle. In elastic strain, the material would change shape when a force is applied and return to its original shape when that force is removed. So, for example, this deformation is reversible. An example of such an elastic material is a rubber band. When I apply a stress, the rubber band changes shape. But when I remove that stress, it returns back to its original shape again. So I apply the stress, changes shape, remove the stress, and it returns back to its original shape. In brittle deformation, when a stress is applied, the material will break or fracture. Although initially elastic, this piece of wood will fracture if I rapidly apply a strong force. Elastic materials, including rocks, will change their behavior and become brittle under the right conditions. And yes, rocks do behave elastically. When the force being applied increases, an elastic material will eventually reach its elastic limit. Energy will continue to be stored in elastic deformation until its elastic limit is reached. At that point, it will behave like a brittle material and break or fracture. This can be illustrated again by our rubber band. So, if I again apply a stress to the rubber band, it will change its shape. Remove the stress, it returns back to its original shape again. However, if I keep applying a stress, eventually I'll reach a point at which it reaches its elastic limit. Ow! Okay. And when the rubber band breaks, it releases all of that stored energy. And this is what happens in an earthquake. Rocks begin deforming elastically, and when they reach their elastic limit, they fracture, and the result is a fault. Lastly, in plastic deformation, the material will change its shape when a force is applied, but that change of shape is permanent. Examples of plastic materials are silly putty or the steel rod. So I apply a force, and they change their shape. But when I stop applying the force, these materials remain deformed. Do the same with silly putty. Apply a force, change the shape. I stop the force, and the deformation is permanent. When rocks deform plastically, they create folds. Rocks are more likely to behave plastically when they are hot. As a result, folds typically occur in rocks deeply buried below the surface where temperatures are high.